talking about managing design and manufacturing data across the enterprise and how that contributes to a digital transformation strategy. And we'll start off here. This is a bit about Jeremy and myself. I work as an account executive with IMAGINiT and am specific to product lifecycle management. Jeremy is our technical expert. He's a mechanical engineer with about 20 years of experience and is one of our lead PLM resources here at IMAGINiT Technologies. Just a little bit about IMAGINiT first. IMAGINiT Technologies is a wholly owned subsidiary of Rand Worldwide Corporation, which is a family of technology companies that acquire, resell, create, and implement technology for our customers to increase efficiency, profitability, and quality. We're the largest Autodesk partner in North America and have an extensive reach with more than 40 offices and around 450 employees last that I checked. Our engineering group has more than 120 subject matter experts with competency in all major engineering disciplines. We are large, but we also pride ourselves in being the best services team in the industry. There's a few other companies underneath the Rand Worldwide umbrella, including Rand 3D, which is a leading provider of Dassault software solutions and both Dassault and PTC training. Ascent is another partner that develops professional training materials for Autodesk, PTC, and Dassault software. And we also have a couple of brands, the first one being IMAGINiT Pulse, which is an integration platform that we're going to be discussing a little bit today, and Productivity Now, which is a powerful and customizable e-learning and testing platform. So now that we can get into it, today what we want to talk about is the way that traditional business system architecture leads to a siloed workplace and a disconnect in data transmission. Every organization in a company typically has some type of software that's crucial or critical for their day-to-day tasks and operations, but it is fairly rare to see those systems interchange data with other teams that have different job functions, but still need visibility into all the data generated during design and manufacturing projects. That's usually left up to things like shared drives, email, manual transmission of data, and meetings where unnecessary time is used up to pass on product knowledge from one group to the next that leaves room for miscommunication or working from incorrect data. There's a lot of ways that can create issues in product design and manufacturing processes that end up causing bottlenecks, delays, and other problems along the way. So in my time with PLM, I've visited a lot of companies that are interested in more refined process management strategy. And what I generally find when we talk to companies that don't have a PLM system is that there's almost always some inefficient product development processes that are fairly standard and just happen, because of the way the technology kind of shapes up. A lot of the things that we see are people walking between departments, sharing information on USB drives, people sending product info in emails, product data getting stored in Excel, sometimes even 3-ring binders, and it just contributes to a very chaotic workflow when you're talking about data continuity and trying to establish accurate, data and processes. When we visit companies, it's really interesting to see how the different departments work without a PLM backbone. We very often see missteps in communication and transmission of outdated or incorrect data, and that leads to delays, whether that be in time to market, issues with quality, or increase in production costs. Both time and materials suffer when the data isn't in a connected source. So those are the problems that we see as pretty much the most common issues in design and manufacturing processes. And what it really boils down to is collaboration throughout the entire business or the entire enterprise. Now more than ever, especially with the advent of COVID-19 and distributed workforce, we're seeing issues that are caused by the distribution of employees we're seeing problems with information overload and the ability to easily exchange accurate data, and multiple disconnected data sources that are all rapidly and independently changing throughout your design and manufacturing processes. And what we want to look at today is how we can help solve that. So PLM is the way that we want to approach that. It allows you to get back some of that wasted time and increase your product quality and time to market. PLM really establishes a digital backbone for your data that becomes a single source of truth throughout the entire enterprise and eliminates gaps between different groups in the company while ensuring reliability of your data. What we're going to show you here today is how Fusion 360 Managed PLM can make that happen. We're also going to show you how we leverage IMAGINiT Pulse, which is a middleware integration platform that we use to connect all these typically disparate systems and allow PLM to really serve as that backbone for all the data coming from all these different sources in your company. This workflow really kind of shows how PLM bridges those gaps along with Pulse middleware. Typically, you'll have someone generate some data, which creates a project. The creation of that project, in turn, creates more data. These are all typically siloed, but what we're seeing here is these orange lines that are actually integrations from different systems, putting everything into the Fusion 360 Managed backbone. So no matter where the data starts, it ensures you're always working from the same info and correct info no matter where you are in the organization. Changes at any point in the process are visible to anyone involved, and they're easily traceable because they leave a breadcrumb trail so that you can ensure their accuracy and that the data is current and not outdated. I think we can kind of move along. Jeremy, I can turn it over to you for the demo portion.
All right, yeah. Hi, everyone. So like Sean says, I am going to be using Autodesk's Fusion 360 Managed PLM software to show how you can sync data and standardize data across the enterprise software that you may be using. I am going to be doing 3 or 4 scenarios based on time to show this. And starting right off the bat, when you get into the software, you land here in your dashboard. I'm not going to give too much of a tour of the software. We have other webinars for that. I'm gonna focus on the data transition and digital transformation part of this. But quickly, a quick little overview is that you land here on your landing page, and it is a cloud-based software. So every company will have their own tenant, and if you have an internet connection, you can log in. And given that, the software is set up into workspaces, and we are going to start. Well, a quick show of what some of the examples are of workspaces is in product development. You have your items and bombs. You can do design reviews in here, store documents. There's some quality capabilities. And then we're going to start with doing NPI, or new project, in here. So I'll start with projects. So right off the bat, we have a scenario where, if you're using spreadsheets or some other sort of new product development tracking software, having it in here gives a centralized location right off the bat to store a lot of the information that goes along with your project development cycle. And the fact that it's in a PLM can quickly tie over to the parts themselves, and then have that information readily available. And that's what we'll show right here. But a quick showing of what we're looking at here is the overall data fields and metadata for the project itself. So we're going to be looking at a clamp today. So I'm calling this the clamp demo. And I haven't filled out too much of the information in this, but you have this type of information that you can track for the project, including KPIs and your progress of how it goes along in the stage gate process, which looks like this right here. So we have a stage gate process set up to run through. Few other bits of information, gathering priorities and efforts and time, the stuff you'd expect in a project, along with a Gantt chart view of the project cycle, right? Tied to your phase gate process. So all the things you would expect in project management, including tasks that need to get done during each of these phases. So now, given this new clamp that we're developing, in the concept, let me jump here. I've jumped ahead a little bit for the sake of the demo, but for the sake of this demo, we're in the concept phase of project development. And one of the tasks for concept is to preliminary bills of materials, is to release to get those going as part of the concept. And if I open that up in another tab, this is actually a task to create the preliminary bill of materials in PLM here, early concept phase ones, right? So even this task itself has its own separate workflow to be done. So it can get assigned, be in work, and all the way to when it gets completed. So at this point, it's been assigned, and it goes to the engineer who in this case would be working in Vault and Inventor to do this design. So I will jump over to Vault, and here's the clamp assembly that I'm working on as the engineer. It's a work in progress. It's just a revision 1, a pre-release, and we have our separate parts and drawings going already at this time. So what I will do with this is right click and send this working file to Fusion Manage. Actually, real fast, what I want to show is back over here, there's another workspace. So this is our new product development workspace. If we look at product development, there's an items and bombs workspace also, and it's empty. Right now we have no parts in our system, just for the sake of showing how this works here. So I'll go back over here, and as I was doing, I will right click and say send working file to Fusion Manage. And you'll see it's doing information here to push this over. So what we're doing here is, since Fusion Manage is a cloud-based system, it has a RESTful API. So any other software that has also an open API or RESTful API, we can talk to using a middleware, which I'll show in a minute. But that's the gist of the webinar here is using these APIs, we can communicate and sync data back and forth between any other system that has an API and documentation that would allow that those metadata fields to be synced. So we're done. I'll jump over and show this middleware real fast. So we are using our self-developed middleware called IMAGINiT Pulse. And so this is what sits between those APIs and sends sequences of code between the two to process that data exchange. I'm just showing this because just to show that it's still processing at the moment, so we can see when it's done. You wouldn't have to do this as a user. This would all be done. You would see when it's done inside of the process. However, in this case, I'm just showing it to demonstrate all the moving parts of the system. But if we go over to here to the items and bombs and give a refresh, see if we have any yet. Yep, there we go. Was empty, and now we see these parts have been pushed over into the system. We will wait and see if this is complete, and it is. So now we have all the parts that are in Vault pushed over into PLM. Saves a lot of time right there, a lot of engineering time, which could be better suited to doing actual design and development. If I click one of these parts, like the base left, we'll see, the part number, and all this information was brought over from Vault. You got your description, dimensions, if those were coded as attributes in there, details and keywords, all these things from the iProperties of the inventor file. And we also have Vault information synced, right? So right there, that's the use case that we're talking about, is having all this data simultaneously available in both systems. Another cool thing that gets brought over as part of this is automatically brought over the DWIF files of these parts. Actually, this is a boring part. Let's look at the actual overall clamp. Here's the overall clamp assembly. It has a bill of materials here that was created via Pulse, and we have the files that were brought over. And I'll open up this cool one. Sometimes it takes a refresh here. The first time it loads can take a second, but there we go. Very nice here. So we have the CAD file, and what this does is helps democratize the information out of Vault to the rest of the company that has access to the PLM. So people can look at this, take measurements. If you're on the floor and there's a measurement missing from the drawing, you can get it right here without having to stop and walk back to engineering and get an update to the drawing. You can keep moving, get exploded views. Maybe you don't have the view you need in the drawings. Lots of really powerful capabilities here, just right in browser, which is pretty cool. We're not going to get too much into that though. We're talking about the data and keeping that synced. So what we will do at this phase is put this part on an ECO. So we can quick create in a change order. Ignore the different types here. They're all kind of the same, but really what we're doing is we're putting this on a change order. We're going to call it prototype release. Ooh, that's in the title. Prototype release. And we have a template, an ECO template that we can use here. And what we are doing here with the life cycle is this is a pre-release. We're still in the concept phase. It's not going to production yet. And I'll show what that means in a second here. So what we've done is we've created a change order in the change order workspace, and it's automatically attached the clamp in here. And since it's a pre-release, it's going from an unreleased blank to, at the end of this, to a Rev 1. What we'll do here, which is very nice and saves yet again a bunch of time, is to add the related items of this clamp. We're going to add all the children. We're going to search for them. It's going to know that these are all the children in the BOM. We're going to add them, so they're all here. And we're also going to bulk change all the life cycle states so that they're all going to a pre-release Rev 1. So anyone who's done an ECO in another way, like in a spreadsheet or something else, and has had to populate out a whole bunch of parts in a BOM, you can see how much time that saves. Pretty cool little feature. So now that we have all of these on an ECO, we will look at the workflow for this ECO right here. And you can see we have a its own workflow, much like the product development and tasks. So in this case, I will start with a submit to get this going. And since this is just getting it into the system, I'm going to fast track this one. The next scenario we'll use the full flow, but in this case I will submit the fast track. Now what this does is this actually uses Pulse Again, so a lot of the scenarios that we're running through today, these pulse uh, syncs of data back and forth require some sort of trigger, and we're using this workflow as a trigger. Anywhere that you see this asterisk, it means that something is happening with Pulse and talking back to Vault. So in this case, when we're submitting it to a change control board review, we want to put the documents in Vault into a review state so that no one can be changing them while they're being reviewed. If we look at Pulse, it should have another sequence being fired. And if we go over and refresh our Vault, yep, we can see that all of these drawings and models have been put to a for review state. Very nice automation right there. So going back to our change order here, oh, and what I can also point out is with the affected items, if I open up this this base plate left, hasn't quite. I don't know, let me give it a refresh. Hold on 1 second. See if there's another sequence firing. There we go. We got one more sequence processing. I'm going to give this 1 second. Now that that's complete, should get what I was looking for here. So this base left now also shows all the vault states as being for review here on this item. Going back to our change order, I go to the workflow. I have the ability to approve. I'm a member of the change control board review in this scenario. So I can approve this, which I will. And on this change order, since I was the only required person for the CCB, it automatically transitions as the final approval over here to the release state. From here, I can push this to the ERP. I'm not going to. That's our next scenario. And there's an argument to be made that it doesn't make much sense to push prototype stuff into the ERP yet because it's not released for production. But that's what we'll be doing in the next scenario. However, what this is doing is setting everything from a review to a release state. If I look at Pulse, we should have a couple more transitions firing. Yes. I'll look at Vault with a refresh. We now have all of our parts released at revision 1. So PLM completely controlled the life cycles and the revisions of Vault right here. And we got one more bit processing. But if I go back over to our parts here and we'll look at another part, what we'll see is that there is now a release, pre-release Rev 1 and a working version of each of these parts when there was only a working version before. And this, as soon as this is done, we'll say released. Wait for this to complete. So it takes a couple seconds, but it's definitely faster than doing this type of thing manually and flipping all 12 models and drawings through their states. Got to complete, and then here, to finish us up, there's our release state of Vault in here, and everything's at a Rev 1. So that concludes scenario 1. I'm going to quickly jump into scenario 2. All right. So now in this scenario, we are back in our new product development cycle, and for the sake of speed, we are just going to fast track to production toward the end. So a couple months later, or whatever your cycle is, we're down at production, and we've generated a task to release the final bombs. All right. So in this case, by some miracle, we've the bombs haven't changed throughout the rest of this development cycle. We will go back over to our clamp, which is at Rev 1, with its bill of materials, and we'll follow a very similar process where we will put this on another change order, and we'll title this initial release. And in this case, it's not a design revision. We're not going from 1 to 2. We're actually going to go to A. So quickly, similar to what we'll do before, I will add all the children. So here's all the children that we will add. And I will bulk life cycle change them all to a release for production. Okay. If I go to our workflow, I can start by submitting this. In this case, I'm not going to fast track. In this one, I'm going to go a full task, initiate task. So here's what we'll get. We actually get a validation warning that you can't initiate tasks because there's no dates on those. So if I look at the task planning here, we have some from the template. We have some templatized tasks that come in with each of the ECOs. And in this particular case, I'm going to remove these, but I will add a task called set bin locations. So since we're releasing these new parts, we want somebody in inventory control to pull a couple of new bin locations for them. This is just a low priority. I'll assign it to myself. And what that warning was earlier is that we need a target completion date for any task. So I'll just say today. Should be able to save that. And now if I go back to my workflow and initiate these tasks, you can now see a schedule. These tasks have been added to a Gantt chart type schedule, and that task has now been assigned to somebody, and they've gotten an email, communication back and forth email for all of these steps, saying, hey, we're releasing some new parts, can you get a jump start on the bin locations? At which point they can open up this task and complete it, much like the project development tasks. This workflow, they can complete it when they're done. At which state it'll close that. We'll go too many things open. So actually, I should probably close that. So let me see the test planning. Do I have it open. Let's open this up. In the workflow, I will acknowledge that I have this task, and then I will complete the task. At which stage, back here in my approval workflow, the system's smart enough to know that all those tasks that were listed here are done, and somebody needs to review the results and say that they're okay. I will say that yes, all the tasks have been done. Let's change this over here. So the same things are happening here. Pulse is firing and is transitioning these items. So if I go to Vault and refresh here, we should now see that all of these have been transitioned to an A, and we're at a work in progress. They were at a work in progress during the tasks. Now they should be switching to an in review. If we look back over at our pulse, yep, we have some processing going on. Okay, we now have Vault. Everything's for review at A. Give this one more second to complete. There we go, we're complete. So I here will approve these being released to A. Second here. I'm going to pause this while it processes and come right back when everything's released. All right, we're back and everything's finished processing, and now we have our released version A of all these parts in Vault. And going back over here to our items and bombs, and we look at our base, we have our pre-release superseded 1, A, and then there's always in PLM a working version out there with this data synced. So what we will finally do in this scenario is in this approval workflow, since this is a release part and we have bin locations for them, we'll push this to ERP. So here I'll push to ERP. And in this scenario, we're using NetSuite as the ERP. Let me make sure that this runs smoothly, and then we'll jump on over. All right, so we finished processing this, and this is pretty cool right here. If we go back over to one of our parts, looking at our base left, if I give a refresh, before we had only looked in the vault section of this with the vault information, but now we have an ERP section with ERP information that again can be synced back and forth, and even have a link right here, which if I click on, brings me into NetSuite into that item itself that was pushed. Again, I don't have to say if you've ever been, if you've ever had the need to enter a BOM after ECO approval into an ERP system manually, it is a huge time suck. And right here, we just got 12 parts into the system very quickly and guaranteed to have matching data across. So same part number, same description, all that information is in here and automatically synced, which is very, very cool. So going back and looking at the part, we're not syncing any unit costs yet or anything, but we can do that in a future scenario. But this is just an ERP section. If you say you had a CRM or a Salesforce section or some other software with that API that I mentioned, you could have this comparable data pushed back and forth for your product development or your project cycles. If you do projects on an engineer to order basis for your customers in Salesforce, that type of information could be synced in a very similar scenario. So I think we're going to do, if we have enough time, we'll do one more scenario and see you in 1 second. Okay, so in our third scenario here, we have a problems report workspace, and let's just say that we've been producing this new clamp for a while, and someone on the floor put in this problem report requesting that, hey, the plate on these clamps is pretty sharp, has some sharp corners. Can we get those rounded so we can stop cutting people? So they've put in this for the clamp that we've been working on. And what we'll do is they will then submit this for somebody to take a look at. Upon a manager or somebody reviewing, submit it for a technician to take a look at. In this case, the engineer who probably designed it. Oh, confirm there. At which stage the tech, who I think I'm assigned as in this, could say, yeah, you're right. This is a good thing. We should change this. Let's make an engineering change order out of it. So we'll initiate a change order or a change request here. And in these scenarios, there's nothing going on with the integration. There's no need. This is just all living within the PLM. But what the PLM did do is, in the related process, automatically created another change order, a brand new one, with and attached this affected files that were in here with this. And transfer that information over. So now that this is on an ECO, we will take a look at the affected items, and we want to rev the overall clamp assembly and that base plate. So we'll look at all the children. Let me go back. And we just want the plate to be revised. So we'll add the plate. We will edit. We'll change both of these to a production revision, so they'll both go to B. At this point, we'll save. Oh, I did that kind of fast. Let me go back to the affected items. So you'll see these will be, at the end of this, we'll go from A to B. I'll go to my approval workflow. Submit. There should be no tasks. Oh, so we need a task defined. I'll just quickly add a dummy tasks in here. We'll add, so not only do we have to update the drawings, we also want somebody to actually do the rework here. So, so we'll actually do the part disposition. Any inventory. So what we've done here is we've included part disposition in this ECO, which is a very common need for ECOs. Usually, you're going to want to the ECO may cause you to want to scrap a bunch of material, or to rework some material, or or use until depleted. And so what in this scenario we're going to do is we are going to use the pulse to get that information needed for the part disposition from NetSuite. So we'll bring back over the part cost and the amount on hand to determine how much it'll cost to do this rework. So now that I've created this task, I can go to my approval workflow, and notice there's a get ERP inventory step here. So we can get the ERP inventory. I'll confirm, and we'll give that a second to process. Okay, so now what we've done is we've gone, Pulse has gone out and looked at the item in NetSuite and grabbed the purchase price. And in this case, we just grabbed the safety stock level because for the sake of the demo, I didn't want to go and do an inventory adjustment or issue a PO and receive it to get actual inventory. But so just for the sake of this, we're writing the safety stock level back. And if we look at the plate here, we have our unit cost and quantity written back here. So part of our change order, which is up here now, inside of the affected items, there are these, we haven't covered these earlier, but there are these disposition capabilities attached to each of the items. So if I edit this, I can say in this case the change performed is going to be a rework. Actually, this is rework. Round corners. In stock quantity we've gotten from ERP is I think 10 of them. Location is like a bin location, and we can say this is going to cost us, like if this was a scrap, we could use the value of 10 times the cost of them to scrap. But rework, we'll just say it's gonna take us $50 in rework hours. So now you can use all the information available to you to make these engineering decisions, including cost impact analysis here, given that everyone's working off the same bit of information and it's all pushed here, and you don't have to go and pull it from all the disparate sources, right? So we now have the information we want to change. We have our tasks, and we should be able to initiate the tasks now. There we go. And so now it's time to perform the change. So what we're doing here is we're taking the vault files, which were released, and putting them into WIP so that we can change them round the corners and and then check them back in for this review. So I'll jump on over to Vault and do that now. So if we jump back over to Vault, we can see that we have a Rev B that's a work in progress now. What I will do is I will open up this plate, check it out. Open this. We'll just fill it some corners. Okay. Remember to check that out. Close it, save it. Check it back in. Here our Rev B. It's already filled out for us in the title block. We'll say rounded corners. Okay. Give this a save also. Check this back in. Go back to Vault. We'll also open up the clamp assembly. This is also now our Rev B. Okay. Save and check all these things in. Go back to my change order. I will say that the tasks are complete. Let me see here. Both of these tasks. So I've updated the drawings. I've completed that task. In this case, maybe you shouldn't rework it till after this is approved, but for the sake of this demo, we'll also say that the work has been done on the floor. To do the rework, we'll complete that task. The results reviewer here. So somebody can review this, or I can review it as the coordinator and say, yep, everything looks good. Let's send it to everybody to take a look at. So I'll confirm. Oh, I didn't have any CCB approvers. Let's edit that. Set myself for each of these approvers. There we go. Since I added that template, it added these tasks. Just kind of did that out of order. I should have signed the template earlier, but for now we'll just remove those. Save. Go back to our approval. Did that a little bit out of order, but that's okay. And now we'll submit, and everything should be okay. Cool. So now, while everyone is looking at it, it should switch everything to the two documents to in review. I'll pause real fast while it does that. All right, so that's finished processing, and so now anyone in the review board can go to the affected items. Maybe take a look at what's changing. Oh, they're rounding the corners on the plate. What does that look like? We open up the plate, go to our files. Here's our new rounded corner version. So this is the Pulse pushed these documents back and forth automatically, again saving engineering time, and then also getting this information in the hands of everyone outside of engineering who's part of the review. If it's quality or production or even marketing, if this is a new product release. So I'm looking at this, I'm saying, yep, you rounded the corners, looks great, good idea. Go back to my change order. Approve. At which point this is released, and similar process to what we've seen. And also at this stage we can push to ERP, which can do a number of other powerful things, like push these new drawings over if the ERP has the capability of doing that. So then you can always have the latest drawing available and to be easily attached to POs. So every time a PO is issued, you have the confidence to say that the latest drawing is always available because they've been synced across all the systems. That's really what we're getting at with this. So hopefully we've been able to show how PLM as a backbone across systems can really help save you time and money, and make processes standardized and a lot of the work a lot easier and automated. So I think at this point we can stop and take some questions.